morning everyone and good morning Miss. I am here today to start my midterm examination on lungs and heart dissection. So, the reason why we are using the pig's heart because it works similarly to the human heart. I am now ready for the dissection process. So, let me first present you the organ that I bought. So, this is the whole pulmonary system, the larynx, trachea, esophagus, the right and left lung, and the pumping muscle that is the heart. So the first thing to do is to separate the heart and the lungs. So let's first since I don't have the right equipment for cutting the tough tissues, I will use the metal scissor for now. So we have to be careful to cut the major veins. So here is our heart. So the first thing to do is to know the posterior and the interior part of your heart. So there are many ways to know the posterior and the interior part of the heart. So we will know that this is the anterior part of the heart because we can appreciate the interventricular sulcus elongated here. And the back side is the posterior side because we can see that the interventricular sulcus is going down to the apex. And we can also know that this is the anterior part because the auricle or the atria here is flapping forward. So now we will now identify where is the right ventricle, left ventricle, right atrium, and left atrium. So here is the right ventricle, right atrium, left atrium, and left ventricle. So the first thing to do is to locate our superior and inferior vena cava because it is where the blood flows first. Let us use our improvised probe to guide us where the superior and inferior vena cava. So this is the major vein, the superior vena cava and the inferior vena cava. So let us cut the superior and inferior vena cava to gain access to the right atrium. As cutting through the superior and inferior vena cava, we can now know the major part of the right atrium. So here is the foramen ovale. So the foramen ovale, it is a hole between left and right atrium that allows blood to cross atria during fetal development. It is now closed because the pig was delivered successfully. So below the foramen ovale is the coronary sinus. So here. So the coronary sinus, it is responsible for draining most of the deoxygenated blood leaving the myocardium. So this one is the wrinkles of the heart, which is called the tendinae. So let us now cut this to to see the right ventricle. We can use your hand to make it as a probe. We slightly shift up, following the interventricular sulcus. So we have now gained more access to the right part of the heart. So we will now proceed to identifying the major part of this right part of the heart. So we can see that there is like heartstring in the middle part of this, and this is called the chordae tendineae, and below this is the papillary muscles, and above the chordae tendineae is the atrioventricular valve, or specifically tricuspid valve. So the fourth destination of the blood flow is the pulmonary trunk. Here. So we may cut it again to gain more access to the pulmonary trunk. As we can see here, as opening the pulmonary trunk, we can also see these three pocket-like. So once the blood pump up, some will fall back down due to gravity. So this pocket-like will fill up. That will create like a seal which prevent blood from falling back. So the blood comes out to the heart, then goes back to the lungs and pick up the oxygen it needed, and then comes back to the left side of the heart, which is the pulmonary vein. So now let us locate where is the pulmonary vein. So here is the pulmonary vein. Let us again cut through this to gain more access to the left side of the heart. Following again the interventricular sulcus, so now we can already see the left part of the heart. So let us now proceed to identifying its major part. So here again is the heartstring, or the chordae tendineae, the papillary muscle, and the valve, atrioventricular valve, specifically the bicuspid blood. So as opening the left side and the right side of the heart, we can see its difference from its thickness of its muscle. So the left side is thicker than the right side, and it makes sense because the left exerts more effort than the right part, because the left side is responsible for distributing blood all over the body, while the right side will only pump the blood to the lungs, which is just right next door. So the last destination of blood is the aorta. So here is the aorta. So let us review where first the blood flows. So the blood flows first in the superior and inferior vena cava, entering the right atrium, then the right ventricle, then the right ventricle pumps the blood to the pulmonary trunk. So after the pulmonary trunk, the blood goes back to the left side of the heart, coming through the pulmonary vein, then goes to the left atrium, then goes to the left ventricle, then goes up again to the aorta. So that's the end of the heart dissection. So lungs are found just behind our ribs, inside our chest, and responsible of exchanging the gases between the air and our bodies, taking in the oxygen we needed and getting rid of the carbon dioxide. So this is our pulmonary system. So when we breathe in, the air passes through your nose or mouth, then arriving through your throat. Then we can see this thing here, which is called the larynx or the voice box, and attached below is the trachea and esophagus down to the lungs. So the first thing to do is we remove this larynx here. So inside the larynx, we can see here is the vocal cords that is responsible of our speech, and we can feel this if you touch your throat and we go ah. Then here is the trachea and esophagus. Let us first remove the esophagus. So the esophagus is where the food passes through. So as we can see in the trachea, there is these rings of cartilage. So these rings of cartilage help the windpipe open and give the air the clear passageway going down to the lungs. So we will now open the trachea to know what's inside it. So as we can see, as opening the trachea, we can see the white foamy stuff here, and this is called mucus. So the mucus help prevent any bits of dust from entering through the lungs. So the bottom of trachea. And we can see it branches off. It branches off into two tubes called bronchus. So the air passes through here and then into the lungs. And now we will now open one of these tubes to know what's inside it. So just like a tree, these branches are getting smaller and smaller, becoming bronchi, and the smallest one is called bronchus. And the end of this bronchus, we can see a microscopic structure called alveoli or air sacs. So the alveoli or air sac, this is where gas exchange happens between your body and the air. So if I'm going to cut this tissue here, we might be able to see what's inside it. So if we put this tissue here in the water, it will surely float than a tissue from the heart. So we will cut some tissue in the heart if it will float or not. So here. So the tissue of the heart submerged to the water while the tissue in the lungs just float because the tissue of the lungs are air-filled. So the other way of knowing that the lung tissue is air-filled is this way. We will cut some of the tissue here. And try it with the 10cc syringe. So here. And if we again put this in water, it will surely float. So that's the end of my lung and heart dissection.